In our online store, customers are constantly buying and sometimes they are also returning items. Also, we have a subscription plan, which is also a product that we are selling, but subscription plan is not a digital product or a physical product. So we are making this a direct subclass of product. So this is what our code looks like. But in a real world application, you could have hundreds of products. Each of these products have very different ways in which they can be returned. A book can be returned in a certain way, TV is returned in a certain way, and you also find that certain products like music file or ebook cannot be returned. So I'm going to add a function called processing returns function. This function would take any a parameter of type any, and since you see here that any is the root of the Kotlin class hierarchy, every Kotlin class has any as a superclass. This approach quickly becomes a nightmare because every time you add a new product, you have to go and modify this giant if else block, because you could have hundreds of products in your online store. This could be a very, very big if else block, and it's not, it's going to, you have to change it every single time. It's not easy to maintain such a block of code. It's hard to read and it's very fragile. So, what is the solution for this? Yes, we can have a process returns or a return policy function in product. So what are the problems that you can face if you put this function in the product? We can then have our individual products override this function. The problem is, in that case, you know that our digital products don't have a return policy. So digital product will, of course, it will not override, but then digital product is a product. So a digital product then pretends to be a returnable, and this is wrong because a digital product is not a returnable product and it's going to violate a lot of software principles. So we can't have our return policy inside the product superclass. So what about, we know that digital products cannot be returned. So what if we have it inside the physical product abstract class? We can have a function called return policy, and it's going to be an abstract function, and the individual products here can override, either provide the implementation for those, for the abstract function. Again, here you could have some physical products that are not returnable, maybe some clothing or shoes or whatever. Then in that case, again, you are forcing a non-returnable product to override or provide an implementation for a function. Again, that is violating the principles, and you are forcing a product that is not returnable to pretend to be a returnable physical product. So again, another solution is you can have an abstract class called returnable product, and you can have individual classes who implement this abstract returnable product class. But Kotlin does not support multiple inheritance. So in Kotlin, you can only inherit from one single class. You cannot inherit from multiple classes. So since book is already a physical product, book cannot inherit from another class called returnable product. So that is also ruled out. So the solution is interfaces. So let's take another example. And here you see that I have introduced something called as gift card. So gift cards can be redeemed, but you see that gift card is not a product. It's not a product. It doesn't come under the product hierarchy. However, gift cards are taxable. Okay. Similarly, a book and TV are also taxable. All these products are taxable. A gift card is also taxable, but a gift card is not even a product. So it doesn't even come under this inheritance hierarchy. Similarly, what if you want to track the delivery person? So you will be creating a class to represent the delivery person, and you'll see that a delivery person again is not a part of the product hierarchy, but you'll see that the delivery person is rateable. He can be rated, but you'll also see that all these products can also be rated. So what we're trying, so we're seeing a common pattern here, and what we see here is that even though certain classes are not a part of the hierarchy, they are they share common behavior. So this is the problem that interfaces solve. So interfaces define what an object can do rather than what an object is. So when you look at this, a book, uh, a book is a product. An ebook is a digital product. A delivery person is a human. There is no common class between a delivery person and an ebook. There is no common parent class between an ebook and a delivery person. There's no way to connect them. So these are completely disconnected classes. You can create a class called human. Maybe you can create a super class called human, and you can inherit from human, but you can't inherit an ebook from a human class. It won't make sense. But both ebook and delivery person, they share a common behavior called as rateable. This shared behavior, it's not a is a type. So an interface allows them both to declare, yes, I'm rateable, without affecting their position in the main class hierarchy. So basically, classes or inheritance, they answer the question, what is this object fundamentally? And interfaces answer the question, what can this object do, or what contract does it fulfill? So this distinction makes interfaces very powerful for building flexible, sensible, and decoupled systems where different parts of your code only need to know about the capabilities an object offers, not its full complex class hierarchy. Let's now